Good morning, this is Trevor. Today we're working on another XSS lab in Portswigger's Web Security Academy. This time it's a reflected XSS protected by very strict CSP with dangling markup attack. So again, I wasn't able to solve this on my own. I did end up looking at the solution and spend some time making sure I understood that. Let's start by looking at where the injection is and why it's expert, what makes it, I guess, tough. Please remember to like and subscribe. Leave a comment. Let me know how I'm doing. So if we go to my account and then log in with the credentials that were given in the start, we get to this page, right? What's interesting here is that if we do !email equals and then blah double quote on hello, you can see that gets printed out right here. Let's go ahead and inspect that in the form. Right here we have the double quote and greater than sign that we entered, which allowed us to enter in more, which exited the input and allowed us to put more XML, right? The other thing is, as we've seen before, this has a content security policy, and you can see that it is strict default source self. So if there's nothing set, it's going to default to the source. And then there's a couple that are more restrictive. So object is more restrictive and base URI is more restrictive. Everything else has self. What that means is we are not able to do like let's see, input or image source equals X on error equals alert 1. And I'll just leave that so that the trailing double quote and greater than sign closes off the image tag. If I submit that and go to console, we do get the CSP error for script source. So how do we solve this? And by the way, when I was doing yesterday in the video yesterday was that I was just wrong in the, I did like input, autofocus, on focus equals something like this is what I did yesterday. And again, that's just wrong. Why it was working for me, it turned out was a plugin or an extension that I had in Chrome, and that's why it wasn't being blocked by the content security policy. So that wouldn't have worked. And that's why I didn't solve the lab either. Anyway, okay, so back to this one. So how do we get this solved? Let's look at the solution here. And again, we're going to copy this out. And let's go here, Kate. And I'll paste that. Let's also go to decoder and just URL decode that, just so we know exactly what's going on. Perfect. Okay, so you can see that this script executes. Let's clean this up just a little bit. There we go. script. The script executes twice. Once when there is a window name, and one when there is not. When there is, it's going to create an image with the source of the collaborator subdomain. It's going to try to get that image, and it's going to URL encode the contents of window.name as part of that path, as a parameter to that path. When it does not have a window name, so window name is empty, it's going to try to it's going to insert, I guess, XSS, right? So we have ahref, we have our exploit server, exploit click me. So there's the XSS. And then it has this base target equals single quote. So remember, the last single quote is part of location and not part of the exploit. So let's take this and break it down just a little bit more. I think everything else is kind of self-explanatory. The only thing that's not is how window name gets changed, in these two instances, right? So the first time that when we deliver this payload, it's going to visit this URL, which is going to insert this XSS, cross-site scripting, that has base target equals single quote. Once click me is clicked, they're going to visit the exploit again and hit the one that has window name. So how does window name get populated? Through an ahref and a base target. This was new to me, so I built a little Python web page or app, and I built this, actually I was testing why my input on focus worked after the video yesterday, and then repurposed it for this link. So as you can see, we've got an HTML, and we're not going to use the search, that doesn't matter, but we have an ahref with a link, and then we have base target and some text inside the target link. We can put anything here. So let's modify this to, this is in the target. That's fine. Now, let's visit that page. So, local 5000. And let's inspect. We'll go to console and do window.name. You can see that this is empty right now, right? Now, let's click on the link and do the same console window.name. See how what we had in the target field is now in window.name? I think that's pretty cool and pretty shocking. So in the target attribute, all of this gets inserted in as the window.name and is passed so that it could be read by the following domain. So you can see, while this is all on the same website, browser doesn't know that because, they're two different URLs. One is local and one is 127. So this is how we're going to capture and pass information, right? And what we need to be able to capture is, let me inspect this, is this CSRF information, right? We need to be able to get the victim's CSRF token value capture that, and then be able to read it. So the first time they click on the exploit link and take in our exploit, it's going to visit this page. It's going to add the click me link right down here. And then it's going to have that base equals target single quote that is open and what they call dangling, right? So this dangling base is going to, well, let's show you. Let's take, what do we want? We want this. My account, email, click me, base target. I don't need to set that because we're not actually going to click it here, but my account, I think I copied from here. Yeah, that looks right. Okay, so if we look at the click me link and edit as HTML, that looks fine. Nothing changes there. Let's look at base target now. You see how base target has a double quote here and goes until the button class equals double quote? That means it's capturing all of this, including the CSRF value in target. And as we saw before, that means all of this is going to be passed as the window.name to wherever this link goes to. And it's going to go to our exploit server. Once our exploit server gets it, it's going to have a window name. So right here, it'll URL encode the contents, concatenate it, and then try to download an image right there from our Burp collaborator. And that's how we're going to capture the CSRF information. Whew, that was a cool one. So I hope you understand what's going on. Let's work on the exploit for it. So we need, in our exploit, we need to post this and deliver it. And we need a collab server to collect the CSRF token. And then I think we need to do a CSRF attack to exploit that, but we'll see once we get there. What is this lab called? Very strict CSP with dangling markup attack. So Vim, very strict CSP with dangling markup attack. .py. We'll grab our template. All right, let's define, I guess, first the payload. Well, we'll just do this for now. And then we know we're going to post the exploit, which I believe that is in site. Post exploit, there we go. And response body. So blog.post exploit response body equals payload. That's going to deliver it. Oh, we also need to remember to do the collab stuff. So once we've got the exploit, we need to read in. So input paste. Let's do collab results here. Okay, so once we get we'll just print this for now. And then we'll see what we need to do. I know we'll need a URL to code that. We'll probably also need to do some regex to slice up to get the CSRF value. But let's wait to see how that's formatted. Let's change this one to the one that includes a collab as an argument. So it's in utils, parse args collab, parse args collab, and then that should be good. Let's define our payload now. We're gonna do triple quotes for this. I'm gonna copy this. Make it look just a little bit better. We'll do one that. And I'm gonna see how it has, it may be hard to see on the video, but has some different characters. That means there's, so it means that either they're spaces or tabs they're tabs and not spaces. So that's why they're showing up different. So I can fix that. And here you can see the error. Indentation contains mixed spaces and tabs. If I do :re-tab, boom. It replaces all of those with spaces, which is what is good for Python. All right. Now we need to make sure we do F here, because here we need the collab domain. One set args dot, oh no, we do need to args dot collab, isn't it? What is it named? It's in utils. Yep, it's just named collab. Remember, now that we're doing F strings with JavaScript, we need to double up any curly brace that we don't want to be interpolated. So this one, whoops, not that one, and this one. Sweet. Okay, so we got args collab there. Everything else looks fine. We need the lab ID. So this will be base URL to right here. Blog.base URL. href. We need to get the exploit server. Let's do that right now. Let's add that in. We don't return. We need to get exploit URL. So exploit URL equals get exploit URL. What do we need to pass it? Oh, we need blog dot. Okay. And then now we can pass that in right here. So boom. Exploit URL. That will go to, I believe, here. That looks good to me. Let's before we post this, let's print out payload. Make sure everything got substituted correctly, and that it all looks good. So we got errors about requests in line too long. That's fine. I can do, I think right here, no QA. Yeah, cool. Python Very strict. Yep. We'll need two things. So we need one, this URL. Whoops. I just attacked myself. That's fine. We're going to close this one. We're going to close this and this. We need this URL. And then we need burp collaborator client. We need this. Need to paste this, but not there. Like that. Let's try that. Let's look at what we did. Found exploit URL. That looks right. So window. That looks good. Location. Email. HTTPS exploit. No, we're missing a slash right there. We're going to give it, this is the exploit server. We should normalize the exploit server. Well, we already have it without. Does it make more sense to add the slash here or leave it off? That's a question for another time. I don't know yet. Let's just add this. But everything else, looks like everything else looked good. And we have the proper URL encoding here with the ending single quote. Okay. That looks good. So I think we're ready to go there. We're going to post that exploit, which, if everything works right, it means that they're going to visit it. The victim is going to get this, right, which is going to direct them to this URL, which has the XSS with click me. They'll click that, and it's going to visit this script again. This time, it's going to have window.name, and it's going to try to get this URL here, which will pass the results URL encoded, and then we'll paste the results here, and we'll print it. Hope that makes sense. So we're ready to go. Let's run this now. Python very strict. We can just arrow up and see how we did. Exploit posted. So if everything it did, we want an HTTP. We got it. Quest to collaborator. Boom. So we're going to take all of this. We're going to copy and we'll paste here. Okay, so we need number one to URL decode this. From URL lib.parse import quote unquote. Isn't it unquote? I don't remember. From URL lib.parse import unquote. It is sweet. Okay. So let's see how we want to do this. First thing we're going to do is we are going to, what should we name this? Captured info equals collab res unquote And let's print this. The reason I want to print it is I want to see how it's formatted, how unquote does this. We could just guess. Should we just guess to save a little bit of time? If I take this to this, copy, and then go to decoder, we could guess. So imagine it looks like this, right? We could use RE to grab this. So let's just take all of this and go here. We're gonna paste this down here so we have a reference to it. And let's imagine it looked exactly like what burp decoder put out. So pattern equals re dot compile r single quotes. We want name equals double quotes CSRF. That'll be how we know where we are. And then we'll do space value equals double quote. Here we want our capture group. So boom dot asterisk question mark to the end double quote. RE, let's import RE. Got the pattern. We do M for match equals pattern dot search. We want to search the captured info. CSRF token equals M1. Change word CS. Let's print that. Make sure we got it before we go on. Okay. Boom. So only stuff we changed is after. So we don't necessarily have to wait and pull up the following ones. We can just copy what we already have, paste, boom. That looks right to me. Is it LUF, GXX2LB? Yep, perfect. So we have now the CSRF token. So we need, can't we just post to, no, we need them to post. So I think, let's read this again. Yeah, we need a CSRF proof of concept. Okay. We got this. We need to change it to hackerevil.net, right? That's the winning. Yep. Hacker. Let's paste this. We don't need this anymore. Okay, so with burps, so we need to engagement generate. So we need to create a CSRF POC, post that to the exploit server and deliver it. Okay, so we're gonna do that right now. I'm gonna leave this open. I'm just gonna move it to a different window so it's out of the way. Proxy. So if we go to change our account ourselves, let's just do blah@blah.com, update email. Okay, that worked. We go here and view it, and we do. Can we do here? Yeah, generate CSRF POC. That looks right. We're gonna do options, include auto submit. We could generate this. I mean, we could write this ourselves. Let's regenerate. Well, we're going to, so script history push state. This just changes what the back button does. And then we've got the two values. I mean, we've already created it. We might as well just copy it, right? Control C, or we can copy HTML. And we need another, so we need CSRF payload equals triple quote, paste this. We're going to delete this. Form action. We're going to change this to boom blog.base URL. And we will need F here. Do we have any curly braces? I don't see any, so we should be good. All right, change email to hidden value. We want to, and we'll call it desired email equals this. Whoops. I said this. TTD. Doesn't need to be. No, I don't think so. No, doesn't need to be URL encoded, right? We'll do his desired email. Okay, CSRF token. This is gonna be what we put. CSRF token. Value submit. Boom, 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 boom. This looks good. Now we just need to do this again. Post exploit. Response body equals change word CSRF. I don't like this name. CSRF payload. No. Change email payload. Change the word. Change email payload. Okay, we're gonna exploit, post it. Let's after we post it, let's do blog.is solved. We need to give it a second, because if you imagine that the user's gonna get this, they have to visit, the exploit before it gets submitted, password or the email changed, and then we get the win. But we built in a, 2 checks and a time delay, so it should still work. All right, I'm thinking this is it. We don't have requests still, so let's remove this. Let's send it. We gotta wait until it asks for the collab. Remember, I moved that onto a different screen. Where did I move it? Here. So we want the most recent. Wow, there's a lot. It's probably this one. Let's hope. Let's pull now to see if there's any. Nope. So I'm going to copy from here to here. Copy. Go to my script. Paste. Enter. Woohoo! Look at that. We did it. Window 2, window 1. Congrats. All right. Well, that one's a pretty cool one. I liked, from scripting point of view, I liked having to do multiple steps one after another. I thought that was fun. For the exploit, I thought learning about how you could pass information between domains using window.name by using this base target equals. That was new to me, like I said. So I had to practice it, make sure I understood it. And then everything else was fairly similar. I know we haven't gone through CSRF yet, even though we did exploit it here. So let's just break down what we did as a summary, and we'll call this one good. So we first built out our payload. Our payload was from the solution. It had two parts. One when the window name was filled, and the other when it wasn't. The first time this is delivered, the victim will not have value in window.name, so they'll go to this second part, which redirects them to the change email screen or endpoint or page, web page, that's the right word, with a cross-site scripting payload. That payload will have click me as the text, inducing them to click on it. When they click on it, it's going to use Dangling Markup to capture the CSRF token and include that as the window.name, which is then accessible when they visit. So that's going to point them back to the exploit server and this payload with now window.name being filled. So here we're going to grab that and we're going to URL encode that and exfil that to our collab domain. Once the victim has done that, they sit idle while we grab the results from collab domain, decode it, extract the CSRF token, and then create a CSRF payload, payload is fine. That's a web page and has a form that gets auto submitted. That form changes their email to the hacker@eviluser.net using the CSRF token that we have captured. So as soon as they visit this page, that form is submitted. Once that's done, we could log in, or we could solve the lab. Once that email was changed, that was the solving condition. So very cool. If you have any questions, definitely let me know. Otherwise, I'll see you in the next one. Thank you so much. Goodbye.